Now behind the scenes, what's going on? So here I have linearly separable yellow and green. Here I have non-linearly separable yellow and green. Here I have the tree. Here I have the support vector machine. And what we see is what we expect over there. Linearly separable can be done with a line. Here it can't. What is a tree doing? A tree starts with one of the features, x1, and says, where shall I put my vertical line? And the way it makes that decision, there's all these equations that you can look at that sound awfully intimidating. Don't worry about them. Think of it in terms of mixing cocktails, let's say. Concentrations of stuff. It is trying to get, most of those metrics have some notion of the purity of the result. So look at this glass. No matter how fat I make this glass, I still have the same concentration of yellow and green. Until I hit this point, and then I have a little bit more green, so my yellow concentration has gone down. So that's not an ideal place to put the line. If I wanted a purer mix of yellow, this would be the best place. And over there I have the purest mix of green. Once I've done that split, I go, all right, down this branch, anything to do? No, it's all green, so I'm finished. It stops short. How about over here? Anything to do? Well, where can I split this one so I get the purest concentration of green on one side and yellow on the other side? Yeah, that one looks good. Anything else to do? Nope, then I stop. And that's kind of how they work. And when you have this sort of space, it's like trying to tile your poor bathroom when there's a diagonal bit. Smaller, 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 smaller tiles, too many branches. If you actually plotted this in your training data, you might be inspired to do a little rotation of the axes, and then it's hole in one. So then you can actually solve this with a decision tree because you do a bit of feature engineering. You have a lot of situations where lovers of some or other method will say, hey, you don't need that other fancy method. Look, we can do the same thing with our method. They just tamper a little bit with the features first to make the features friendly to their method, and then their method works. So you can do a lot by altering the features, or you can approach it by altering the algorithm. So when do you try this first? When you've got no labels, when you want an easy-to-read model, or when, if this, then that seems like a promising structure for your problem.